Hello, welcome to Navigating NewSpace, a Matthew Isakowitz Fellowship series where we interview various mentors and fellows about their perspectives on the commercial space industry. I'm Madeline Baum, a 2021 Matt Fellow, and I'll be the host this week. For this episode, I had the opportunity to interview Dr. Sandy Magnus on campus at my school, Georgia Tech. Dr. Magnus joined the NASA Astronaut Corps in 1996. She spent time on the ISS and flew several shuttle missions, including the final shuttle flight in 2011. Since then, she has been a leader at the Department of Defense, establishing engineering policy and best practices within the engineering community. She was also the Executive Director for the American Institute of Aeronautics and Astronautics. Currently, she's a professor of the practice at Georgia Tech, where she splits her time between the Guggenheim School of Aerospace Engineering, the School of Material Science and Engineering, and the Sam Nunn School of International Affairs. Thank you for joining me today, Dr. Magnus. I really appreciate your time. First, I want to start off with just a basic question. What do you find most exciting about NewSpace and why?
So after 60 years of government investment, the foundational knowledge of how to engage in space is so broad that even in college, students are building and operating and managing CubeSats. And so with that broad knowledge now, this, as what you're calling new space, has emerged because people now can engage in space with the advancement of technology as well as that breadth of knowledge. So it's super exciting to finally get to the point where space is now a thing that people see from a business viewpoint that they can engage in ways that never before were possible. And so for students, and for people who have creative ideas and for entrepreneurs, it's a whole new era, and it's very, very exciting to see all this energy coming into the space sector, as it were.
Do you think there's a niche in the commercial industry that's currently underserved, or an area in the industry that will be greatly needed within the next decade or two?
You know, I think, in answer to your question, I think the most challenging thing that we're facing right now is this burgeoning sort of new space, if you will, is really understanding what's the market, right?
Yeah.
For example, we're talking about private space labs. I'm a little bit more in human space life, but not entirely. But, private laboratories on orbit that replace the ISS. So the question is, what is going to happen in those laboratories? What is the private sector activities? The government's always going to have things they need to do. NASA will always need a low Earth orbit laboratory to continue to do technology development, to continue to pay for fundamental peer-reviewed science that industry's not interested in doing for the most part, right? Because there's no profit in it. It's fundamental science. But then there's the technology development or the applications that industry could be doing to create new things. And right now it's really hard to understand how the business cases are being closed and people are thinking about it, because there's not really any one entity that's focused on that. I mean, NASA, the National Lab Group, is trying to do that, but it's not really at the level that it needs to be. And so thinking about how to develop the markets, how to generate those ideas of what could happen in space. There's a lot of kind of energy around that right now, but I don't think we've nailed that down. And that really needs to happen in order to really kickstart low Earth orbit activity beyond the CubeSats and some of those applications which are very Earth-facing.
Okay. Do you think, going off of that last question, do you think commercial occupation in space will bring a surge of in situ scientific research? And if so, what type of research do you think might be happening now that wasn't previously?
Yeah, so to carry on the previous conversation, I think one of the things that could happen and should happen to really help figure out what is the right niche activities to build the market and close business cases is to get people up there, right? When you are in zero gravity, you understand zero gravity a different way, because there's a difference between knowledge that's in your head and knowledge that you gain by experience. And so I think if we could figure out a way to launch creative researchers, creative inventors, chief scientists at companies or chief engineers at companies or whoever inside different sectors identify the right people, and you get them up in zero gravity and they have a chance to really experience, that's going to spark a lot of ideas for the type of research that a company may want to sponsor to achieve their end goals, right? The pharmaceutical industry is low-hanging fruit, for sure. Whether or not there's some work going on in manufacturing materials on orbit to take advantage of zero gravity, whether those materials or those finished products might be used on the ground or in space is still a big question. So those are a couple of biggies. What kind of technology could be built or engineering could be done in space to continue human spaceflight to the moon and Mars? That's another area. But these are all very nascent. And I think we still have a lot to understand. But the more people that get up there and experience zero gravity, I think that will start help the situation, and people will be able to connect the dots a little bit more. But until you experience it, it's really hard to understand it. And we still have a lot to learn in the human spaceflight area, because right now, for example, the FAA is not, they're precluded from doing any kind of regulation of the commercial space. Right now, for the private launchers, they have to certify that they're not going to put the public in danger. So eventually, as more and more people fly into space, the FAA is going to have to come up with some oversight for launches. And so what that looks like, and that balance between safety and profit, and the dynamics between what the government's going to dictate for safety and what the companies are going to do on their own, those are still some very strong unknowns. The transition from the ISS, a government-owned and operated laboratory, to a private laboratory where the government is an anchor customer, those conversations are going on, but what that transition looks like, very much unknown. So we have a lot of things that are sort of in thrash mode at the moment as we're trying to figure out how it all works, besides the market part that we talked about earlier.
Mm-hmm. I know you have some background with human factors. What are some major differences, do you think, in how human factors were considered back in the ISS era versus how they're being considered now in the private industry?
Yeah, so I'm not intimately engaged with what's happening, but I will tell you, as engineers in general, we do not think about the operators early on in the design like we should. Mm-hmm. We just don't. And so I would encourage private industry who's more customer focused will probably bring those design considerations forward a little bit more than perhaps happened on the ISS. But we just don't think a lot about if you've ever tried to change the oil in your car where you're like underneath it trying to swirl your arms through this complex set of widgets in the way, it's like, wow, this shouldn't be this hard, right? And that's an operator thing to change the oil. So I think industry will probably tackle that a little bit better because they'll be more customer focused. But the other thing that's interesting too is as more and more people get experience in zero gravity, especially engineers, you'll start thinking about the design a little bit different. I'll give you an example. On the space station, all of the lighting is on the ceiling, or the upper, right. And so why? Because you're used to, in a room, having the lights on the ceiling. But when you access all 3 dimensions, you need lights everywhere. And so there were times when I was working, in a hole, opening the ceiling to work, there was no illumination from the floor coming up to illuminate, right? Because why put lights on the floor? Or the deck. Okay, so there's certain aspects of working in zero G that will eventually be incorporated in designs as well, but we're not there yet. But I have a hunch industry, because they have to be more customer focused, we'll be thinking about it a little bit better.
Interesting. If you were to design like your own private space station, what are some other, in addition to putting lights on the floor, what are some other things that you might adjust? Yeah,
so thinking about the habitability on the space station. When I lived up there, we had the crew quarters, the exercise equipment, the toilet, and the galley all on top of each other, right? And so thinking about how people use the space and and what makes sense for not just the work piece, but the habitation piece is super important. There's always a huge conversation about windows because they're, hard to design and they're expensive to add, and one could argue they're not required, but yet psychologically, is it good to have a window? Yeah, maybe. So that debate will be going on forever. But just thinking again, how is the operator going to use the space? What's the habitability look like?
As we move from government-owned stations to more private ones, do you think the collaboration will become more or less international than it is currently?
I think the collaboration's super international already. I give you the International Space Station. I think that will continue. Arguably, probably more, because more countries are getting engaged in general. And when you have private, one of the advantages of the private ownership of these facilities now is that other countries can contract out to fly their people, and it is perhaps a little bit easier than the 5 years of negotiations that led to the memorandums of understanding that established the ISS program. There'll still be government-to-government cooperation, don't get me wrong, but I think, if like, for example, SpaceX, they've got their capsule, and so if a country wants to buy a ride on their capsule to fly their people, they can. But more and more, I think it'll become more international in general, because more and more countries see the power of engaging in space and the economic advantage of doing it, and they want to inspire their populations as well. So there'll be more and more countries engaging.
What's been your experience with space policy, and do you think what do you think is going to be necessary to really open up the frontier?
Yeah, so we've been very fortunate for the last 10 years or so that the government has been focused more or less consistently on the same goal, which is go back to the moon and then on to Mars. That has been helpful to provide some stability in the space industry about, okay, this is our vision and this is our goal, right? And so that's good. We continue to struggle at the national level with funding. Although NASA has, over the last 4 years or so, got an increase, steadily percentage-wise increase in funding from when I was there, which is good. So I think those are all good markers. And the disadvantage of how NASA, for example, is funded is it's on yearly increments because of the appropriations process. And that's hard from an engineering viewpoint. That's hard to manage because usually in the development phase you have much more of a financial commitment that's required to get over that kind of development hump. And so NASA's having to, do development of complex systems in kind of a wacky financial paradigm. So that's going to continue to be a challenge. But industry engaging and NASA expanding their acquisition methodology is all very helpful. And so just keeping that, that ecosystem going will be important as we go forward.
What skills do you think will be crucial for the next generation of space engineers, and why?
Well, I think, creativity is, people don't think of engineers as creative because you think of creative people as in the arts or in the, music or whatever. And I would argue that engineers must be creative in order to do the things that we do, especially in the space sector where we're building things that haven't been built before. We're working in a domain that, even though we have 60 years of experience, is still kind of new. And I think, bringing that creativity, being able to work on teams is very, very important. And just trying to figure out how we're going to continue to expand off the planet, and thinking out of the box. I think, and it's interesting in aerospace now, we used to be an industry where we pushed technology out, and there were a lot of spin-offs, and the rest of the sectors out there really benefited from the advances in aerospace, and that was really a one-way trip. And now we're at the point where we're still pushing technologies out as we advance, but we're also bringing externally derived technologies in to the aerospace industry. And I think having the ability to continue to look around at what's going on in other sectors and the technology that's being developed in those other sectors and how those can apply to solving space problems, that's, I think, a new dynamic that you will be working with in your career.
Where do you get your space news? What resources, if any, do you recommend to students who are trying to learn more about space?
Oh gosh, there's so many places you can go online. There's a space. I do a lot of reading on space policy, and so Aviation Week is one. Space.com, spacepolicy.com, Space News. I mean, you can just Google space news out there and get a lot. There's technical level. AIAA has several technical journals that track, what's happening not just in space but in aerospace in general. So there's no dearth of information. It really kind of depends upon what level you want to engage. There are a lot of books out there. I have not read. Astronauts write a lot of books just for anecdotal stories. I have not read any of them, so I can't recommend any. But there's a lot going on. The venture capital community, has periodicals about what's going on in space, so there's economic information out there as well. There's a lot out there.
If you were a student graduating today, what type of company would you like to work for within the space industry? Or if you prefer to go the academic route, what would you be researching as a student now?
Yeah, so, I think for a student who's generally speaking, for a student who's graduating, you have to figure out what fits you, right? For some, it might be a small entrepreneurial company. For others, it might be a well-established company because there's certain projects they want to work on. There's also a lot going on in the DoD if you're interested in doing national security kinds of space things. And so the nice thing is there are so many options for students today. You can pick across such a broad variety. I think the research I would be interested in, and I am interested in, now I'm part-time at Georgia Tech, I just have to find time to pursue this, is, I'm a materials person by training for my PhD, and so I'm intrigued with how the zero-gravity environment could be used to manufacture materials, and what materials and what kinds of manufacturing facilities you might be able to build. Because it's, when you think about making materials in space, it's first for what purpose, but more intriguing for me is what is the manufacturing system that you put around it. There are people looking at 3D printing, whether or not there's solidification types of material systems that you can build up there, and if it's practical. I don't know. I have to get caught up with that field. I've kind of lost a little bit in touch with it over my years at NASA and running AIAA. So now I'm at the point where I was like, maybe I need to dig into this. But the point is, there's so much going on that I think for a student, you really need to figure out what your interests are, because not every student should go work at a small company, nor should not every student go work at an established company. You have to kind of figure out what your goals are and what your interests are.
Do you have, for students who are considering grad school, what advice would you give to them as far as selecting what school to go for and what programs, what qualities and different programs they should be interested in?
That's the ongoing question for graduate students, right? Do you pick the school or do you pick the topic? And so it has to be a little bit of both, right? So you definitely need to have a thesis topic that you're passionate about, that you're intellectually curious about. So you can't just roll into graduate school without some interest in the topics that you're pursuing. And so that has to be, I think, maybe number one. And then number two, again, you need to pick a school that you fit with, because different graduate programs have different cultures and they have different vibes, some small, some large. And so in the context of having a subject matter that you're passionate about, then you need to look for a school that fits you. I mean, everyone's like, oh, I have to go to the top school. It's like, yeah, that's not important. There are so many good graduate programs all over the country that there's a batch from which you can select, and you'll be totally fine with a good, strong pedigree degree. And so getting wrapped around the axle about, oh, this one school, I think if that school does not fit you culturally, then that's not a good match. So you have to think about the intellectual curiosity and having passion for your subject and finding a good match for a graduate school. And then after that, once you get out in the working world, it's really all about how you perform and less about, my degree's from X. The one thing that the school does lend to you, though, is access to the alumni network. And that's important.
So what advice would you give to civilian astronauts and the companies who are sending them to space?
Right, and so that's part of this breadth of activity that's happening now is in order to have an opportunity to go into space, you don't have to be, like I was, a professional government astronaut. There are now ways for people to access space as an experience, everything from suborbitally as a tourist to a private professional astronaut, which will be happening. You see some of that at Virgin. We have people who just launched an Inspiration 4 who had a 3-day experience, and so there's a whole new range of experiences that are available to people. And I think the most important things for anybody, if you have an opportunity to fly space, make sure that you take a moment to enjoy the experience and don't get so wrapped up in whatever the job is that you're doing. Of course, if you're going to have the experience, you will. But the companies have to figure out how to train people, what's the safety process that they need, and it's still, I don't want to say it's not entirely safe, but it's still, that safety process is still being managed, and we're still going to learn a lot. But it's a wonderful opportunity, and it's really exciting to see a broad array of people getting that opportunity.
When you were on board the ISS, did you experience an overview effect? And if so, how do you think that affected you as an engineer?
Yeah, so everybody who goes to space is going to have a perception shift about the planet. And it's commonly called the overview effect, as you commented, and really it has a lot to do with, we take for granted things that were around all the time. So for example, I live in the Washington DC area, and I don't visit the museums that much because I can, right? They're in my backyard. I don't even notice them. But yeah, people come from all over the world to visit those museums. So I easily take them for granted. And so we take our planet for granted. And when you exit the planet and you look down on it, you have a profound shift about what it means to be a human being on the planet, what the planet means, the fragility of the planet, the fact that it's, in engineering terms, one system, and it's all connected. And so whether you're an engineer, or William Shatner just recently went up, or an actor, or a business person, a journalist, you're going to have a profound shift in your perception of the planet. And it's going to affect how you approach life. It's going to affect how you approach problem solving. It's going to affect how you approach your attitude about the world. And I think the more people that have that, the better it is for us as a human tribe living here on the planet. But it's very exciting. And I really enjoy when people have this, they come back from this experience, and you'll see more of this as a suborbital launches happen. I really enjoy listening to them describe the experience, because you can tell that they've had that perception shift.
I guess, do you have a favorite moment while you're in the ISS, and or a learning and a teachable moment that you look back on?
Oh gosh, I guess I have several favorite moments. When I was there on STS-135, the last mission, the cupola was now on the space station. When I lived there during Expedition 18, we didn't have the cupola. And And so for 3 nights, during 3 of the nights we were docked there, I stayed up after everybody went to sleep and although Mike Fossum was roaming around one night, but I was up in the cupola by myself, watching the world go by for a couple hours. And it was really awesome because with the cupola, you had a whole 360-degree view, whereas just looking through a window, your view's a little bit limited because it's a porthole, right? So your field of view is not so great, but having the opportunity to just float there and have a 360-degree view of the world as it's gone by, that was pretty spectacular. Yeah, that was one of my favorite moments. And it was so peaceful because everybody else was more or less sleeping, and it felt like I was the only person there. I mean, I roamed through the space station. It's like I was the only person there. It was so cool.
How would you describe the psychology of working with a team in confined quarters like that in such a unique environment? Do you feel that you guys got closer, or what personalities blended well together?
Well, you have to think about it like, first of all, you train together, so you know each other really well. You're very mission focused, and so regardless of any personality issues that you might have, you're very focused on the mission. But think of it like you would think about with your siblings, right? When you grow up if you have brothers and sisters, you know your brothers and sisters really well. You know what makes them annoyed. You know what makes them happy. You can tell their moods by just being around them because you know them so well. It's a lot like that. And so you develop, with your siblings, you develop mechanisms for how to deal with each other. It's a lot like that because you just know these people so well. I think, and just like your siblings, you're tied together with bonds of family, and that's your kind of your mission. But on orbit, you're tied together with bonds around the mission, and it just works. And I think we do a lot of training ahead of time, and they can tell how the team's going to work. I think for Mars, where you're going very, very far away, they'll have to put a huge amount of effort into making sure that the right teams mesh together, but it works. That you do know the people very well.
In your time, having been an astronaut, I'm sure you've been interviewed quite a few times. Is there a particular question that you enjoy being asked the most?
No, I mean, I'm happy to answer questions that people have and talk about what their curiosity is focused on, because everybody's different, right? And we talked a lot today about what's going on in the industry now because your community or the people who are entering the space field. I will just say there's a lot of exciting things going on, and for your generation, it's really, you're going to have a great time because there's so much more opportunity, there's so much more energy. I just have no idea where it's going to go, and it's going to be fun to watch what you guys do. It's really going to be fun.